Okay, so my name is Dario, and today we're going to talk about reusable behaviors in Kotlin. So first of all, let me tell you a little bit of a background story. So I joined a company called Reusable a couple of years ago, and we started a very interesting project that was rewriting the mobile app from scratch, both Android and iOS. Actually. So we went through this journey, and if you ever wrote an app from scratch, you know that there is a lot of things that you need to think about. How are we going to store the data? How are we going to contact the API, etc., etc. But most importantly, you need to think about what is the actual architectural paradigm that you want to use to put all these pieces together. At the end, we come up with something that look like an MVP architecture, customized for what we need, but following kind of high-level principles. The reason why we went there is because looking at how Invoice2Go work, each page that we display to the user always contain UI, obviously, and it has some sort of business logic that we need to apply based on what the user does. So for this use case, like the presenter fits our need to handle all the business logic. And then we decided to add a layer called contract that describe what is the interaction between the UI and the presenter. Reason is you don't want to go straight from the presenter to the UI. You're going to couple too many things. It's always better to abstract a little bit more. So we come up with this simple contract that is responsible to describe and let the presenter know about what the user wants to do. As an example, we can talk about the login page that we have in Invoice2Go. We start by building the contract, in this case, a login contract. We describe normally our contract in two main sections. Producer that describe user interaction, for instance, in this case, a login click or button click, expressed in form of an RX observable string. And consumer that takes care of getting the data that the presenter processed and somehow either display to the user or do some kind of interaction with the UI. As you can tell, we build it a lot around RX because we want to abstract a lot of problem regarding threading or just modeling data. It's much easier this way. Second, you build the presenter. Simple presenter in this case, you just take care of binding basically this contract by taking producer and attaching them to consumer in a very, very simplistic way. So in this case, for instance, we have our login clicks. We map them to some sort of, API call, whatever is happening behind the scene. And in the end, with that bind method, we are using the consumer of the contract to get the data back to the user. In practice, it looks something like that. You press login, something happens, and in this case, we probably have an error because I put a random password in. Nothing. The user is stuck in there. Now, looking at this example, there is another piece that was not described, that is this loading dialog that shows up. So let's look how do we add that loading UX. First of all, why do we add a loading UX? Because we want to tell the user that something is going on and that his tab actually works. That's a pretty common pattern. So first thing to do when we want to add this loading UX is to describe how the loading UX works. And this is what we are going to put inside the contract, since the contract defines our interaction between presenter and the user. Second, we need to put the actual business logic, and that's presenter responsibility. So we need to have the presenter describe the when. So when is that piece of logic from the contract be used inside our business logic? So going back to our initial code, we have the contract and the presenter. We can start by adding the how. So we add the how by adding inside the contract two methods, let's call them show loading and hide loading. And then we move on the presenter to add the when. So in this case, we simply put before and after our, say, complex API call or whatever we need to do. We add the show loading call and the hide loading call. This way, we describe the contract our loading behavior, and we express in the presenter when this should happen. All good. The result is what you saw before. Nice. Now, thinking a bit more about what we just did, we add to a very specific part of the code that should be focused on doing a login operation. We add code that describes a very generic behavior that in this case is loading. So after we did that, we asked ourselves, how can we make this loading part of the code more reusable? Again, like showing and hiding loading is a very common business logic. You do it everywhere in your app when you need to trigger an API call that requires, say, active wait from the user. Also, since it's our like language pattern to the user, we want to keep it as consistent as possible because the user will be able to understand better what to expect whenever he sees this UI. But at the same time, you might want to customize it. Like there are some special cases where some page needs a different treatment for the loading, or maybe you just want to A/B test and you don't want to waste too much time rewriting your code. For instance, going back to the example before, we can have the same loading experience as a dialog or as an inline spinner. And ideally, you don't want to have to rewrite everything, in particular the business logic, since that didn't change at all. You just want to be able to quickly change the UI. So the question is, how do we reuse code without rewriting it? Obviously, there are thousands of answers to this question. There is no perfect answer. We came up with our own strategy, and that's what I'm going to describe from now on. So first step, if you think about reusing something like a loading UX, is to think about what is the behavior that you want to reuse. So as we just say, the behavior in this case is the ability of showing a loading message. And we can take that behavior and express it in the form of an interface. Now that we have an interface that expresses that behavior, how do we make it more modular and integrate in our code without having to rewrite the same thing over and over again? There is one paradigm that does something similar. It's called AOP, Aspect-Oriented Programming, that basically allows us to inject code, inject behaviors in our code without the need to modify the code that is already there. So we wanted to achieve something similar without basically damaging existing code and only taking advantage of only basically adding an extra code on top of it. But at the same time, we don't want to add a framework or complex code that are going to slow down everything and make the code unreadable, etc., etc. So how can we achieve that in a language like Kotlin that has a lot of new modern tools for us? The answer that we found was interface delegation. So interface delegation is a pattern that is not new, but Kotlin bundled it natively in the language. So that makes it very attractive for us because we don't need framework, we don't need libraries, and it's very nice to read. So how do we start to define this behavior? First of all, we need to identify what is the common logic. Again, case of loading UI, it's probably these two methods, show and hide. There isn't much more than that. Once we identify them, we need to extract them and create an interface that is only representing that behavior. And this will allow us the ability to customize the how, but not the when. This is important because, as I said before, the how is represented by the contract, the when by the presenter. We are not here to try to change the business logic. We just want to have the UI part of it be reusable and customizable. So in this case, this new contract interface will be somehow bundled inside our existing contract interface and become part of it, but also stay independent. Let's see in practical terms what that means. So this is the contract that I showed before with both the login part and loading part. So we isolate the loading part, that are these two methods. We kick them out in their own interface. And now we make our login contract implements that interface. What that means is that login contract now has both behavior, the login behavior, the button click and the render, and the loading behavior to show and hide. All nice, now we have a clean interface separation of concern, etc., etc. But what does that mean in terms of implementation? How do we achieve, in practice, like the real execution of this code? First step is to create a generic implementation of this loading contract. Again, we want to keep it completely decoupled from everything else, so we are going to have a dedicated class that takes care only of loading and will not know anything about logging. Once we have this class, we can use the interface delegation pattern to compose it with our logging implementation. Basically, from the diagram before, what we're going to do is we are going to just implement that particular component of our contract with a dedicated class that can be reused in the future. As an example, this could be the login contract UI. So there is like, we initialize it with the root of our page, and we have the login clicks that are just like clicks on a button in the UI. We have render that has some magic rendering things. I didn't put too much code. And then we have the two loading method, show and hide, that were part of the original contract. That in this case, for instance, create a progress dialog, show it, and dismiss it later on. To do that, also we had to create a local variable to cache the dialog implementation so that we can dismiss it later on. And as you can see, it's a bit dirty because we have a login page that now needs to know about loading and has a variable that we don't really care in logging, etc., etc. So let's start by isolating what is loading. And as we said, it's the two method plus that extra variable that we don't really want in that page. We can kick them out and create a, for instance, dialog loading contract class that implements our loading contract from before, and just have the loading logic. We initialize it with the context, since we need a context to create a progress dialog, but we don't know anything about the view and anything at all. It's completely independent. And then the final piece that does the actual magic and put everything together is the interface delegation. In this case, in Kotlin, you do interface delegation by using the keyword by. So, as we saw before, the logging contract contains both its own contract and loading contract. When we implement it, we can say that a subpart of that contract, represented by loading contract, is delegated to a specific implementation. In this case, it's an instance of this dialog loading contract. Now we have our logging contract implementation that only contains logging related stuff, and loading contract implementation with the dialog contains only loading stuff. Now we talk about customization. So how can we achieve customization in this way? We can simply have different implementation of our contract that describe the how, and keep the business logic the same, since the when inside the presenter shouldn't change if we decide to change the UI. In this way, we can achieve consistency, because we can have one implementation reused everywhere. Reusability, okay, used everywhere. And customization, because we can create multiple instances of the same contract and adapt it to different use cases. So for instance, we can have a dialog loading contract or an inline loading contract. Like we saw before, in our example, we have the 2 pages. These are just 2 snippets of code. You can achieve these 2 results just by changing the implementation of the contract, either with a dialog or with a simple visibility.
So a quick Kotlin move question. Where you actually implement, you mix in the implementation, can you leave that abstract? You can say this one needs to have a loading contract.
Yeah, so
an actual subclass will.
Yeah, so in here,
so instead of using by,
if I didn't use that by, the compiler would have thrown an error because the login contract implementation only implement 2.
Could you mark it abstract and leave it to 2 subclasses for mixing a specific one?
Sure, you can do. You can compose it however you want. It's like normal inheritance in this case. Anyway, going back to our example. So yeah, these are 2 examples of how to achieve this 2 UI. The presentation layer stays the same, the business logic stays the same, but we have 2 completely different UI that we can swap, test pretty cheaply, since we only need to change the by delegation. Cool, now a little bit of trivia time, more for people that maybe are a bit more familiar with this. Let's say that we create an interface, call it shape, contains a property and a method, property size, and a method print size. Now we can have a class that implements this interface called square. Square override size, we return 4, and override print size and return a string that simply say the word size and concatenate the property size. Can create another class called Pentagon, also implement shapes, but in this case we are delegating the implementation of the interface shape to a class, to an instance of the class square that we previously declared. Also, we decide to override one of the property from the shape interface called size, and we change it to 5. Why do we do this? Because obviously the Pentagon has 4 sides, but also because we don't want to override the print method, since it looks like it's still valid in our use case. It's still printing size, and it's calling the property size. Now we create our main generic non-Android, create an instance of Pentagon, and we print the result of calling shape.printSize on a Pentagon object. Question: what is going to be printed? 4. Anybody says 5? The GIF is probably not correct then, but yeah, it's 4. Why is it 4 and not 5? Because as a downside, not really a downside, it's more like things to keep in mind. First of all, you should never mix inheritance and composition. These are like 2 completely different things, and when you mix them, the results are dangerous. And interface delegation is not inheritance, it's composition. What does that mean? It means that overriding can be misleading. So we are doing inheritance with the interface, so we are getting all the properties that are described inside the interface. But we are not doing inheritance of the implementation. We are doing composition of the implementation. So this means that the actual body of the method stays in a separate sub-object that is included in our main object. And because of that, if we go back actually to our example here, the print, like the square object that we are using to delegate the shape implementation, doesn't know about the Pentagon object. So when we call print size, since it was not defined inside the Pentagon object, the compiler is going to use the print size implemented inside the square. And inside the square, the only only property that is available is the size that define 4. The override that define 5 is in a completely different object that will never be reachable by the square object. That's the difference between composition and inheritance, particularly with Kotlin. Also, yeah, this is mostly because there is no magic behind the scene. So the way that composition happens is just by creating an instance of the class that you want to delegate to and putting it inside the main class that is implementing the interface. At the end of the day, we are compiling bytecode, so again, there is no magic.
But, I mean, I don't want to be that guy, but Scala does that right.
Sorry?
Scala does that right. So if you do that same thing in Scala, it will actually mix in the implementation. So that's not something that's got anything to do with the JVM. It's just the way that Kotlin.
Sure, it's more like, that's my view in there is that Kotlin tried to be completely compatible with Java. So behind the scene, they need to play by the rule of Java.
Scala with mixing Scala
Mixing is delegation.
No, that's exactly his point.
So I think it's off topic. We've got that.
Yeah, sorry. Let's talk later. Finish this. So anyway, what I was saying is overriding can be misleading. Also, again, it's not in inheritance, so we can't call it super because there is no super. So you can't access from the main class implementation that are delegated to another class. There are tricks you can use creating referencing instances outside. I'm gonna go into these details. Upside, it's not inheritance. Like inheritance, in my opinion, is pretty bad because it leads to a series of problems by creating very long hierarchy of objects that are harder to debug, harder to maintain. So we get higher flexibility and less coupling. Again, each interface can take care of one unique responsibility, and you don't need to, like, each interface doesn't need to know about other things going on in your code base. You can focus then on designing your behavior. You can think about specific behavior instead of thinking about a class that needs to do a lot of things. And in this case, it's much easier to make it right. You can just like have it tailor for that behavior. Also, it's easier to accommodate future changes in a sense that if you want to change just the loading experience in the entire app, you don't need to go around every single class and change how it works. You just change it in one place. And yeah, as I was saying, like it's less prone to error because it's like single purpose. Now, to recap a little bit about how interface delegation works. So, interface delegation implemented the composition over inheritance pattern. It allows us to focus on behavior. I keep repeating this point because I think that's kind of the key of this of using this technique is that you can think about behavior and not about the complexity of your entire feature or part of the app or whatever. You can decouple the code from feature, from network, from anything. You can just have code that solves one problem. And you can have a consistent implementation around the entire app without sacrificing customization, because as we saw, you can easily customize for one specific part of your app and have a different implementation that does completely different UI things. If you want to read more, there's a link of the documentation and delegate all the interfaces. One last piece, bonus. Generic upper bound. So this is another nice thing that Kotlin offers us. So in Java, when you use generics, you only specify one bound, upper or lower, but you can only specify one bound. Kotlin allows us to support multiple bounds for generic types. This means that we can define the parameter of our method to receive only pieces of our contract. By doing that, we can have modular dependencies, and our methods can be more like thinking about behavior and not like how to solve an entire future. To give you an example, so we had a loading contract from before. We can create a new one called error contract. Suppose a show error method that accepts an exception. Then we can have the login contract like before, and this contract can implement both loading and error. And we can have a sign-up contract that also implement loading and error. If you think about it, these two experiences in the app are pretty similar. They both require a loading UI, and they might both fail and show some sort of error. Now, if you want to implement some sort of processing method that is generic enough to be able to accept either a login or a sign-up, but should be able to show error and loading, how can we define the type of that C so that we don't need to write it multiple times or have like complex if casting, etc., etc. Anybody know how the syntax works here? There is a nice where clause that we can add at the end of our method where we can define every single bound that a generics can have. In this case, we are saying that our C should be both a loading and an error contract. This means that we can pass to the process data method both a login contract and a sign-up contract because they both satisfy the requirement of containing a loading contract and an error contract. So this is very useful in conjunction with our technique of splitting interfaces because then we can create these methods that just accept pieces and we don't care if they are being executed with a loading or sign-up, we just care that they can show loading or throw errors. So what do we get again with this generic upper bound? We declare a parameter by describing their behavior instead of their actual implementation. We can decouple, in particular, utility methods from a specific implementation that have to do with the parameter that we are passing through. And most importantly, it's type safe. This means that we don't need to do cast, we don't need to do runtime check. The compiler simply constrains us to only pass the data that actually match what we need for. So a lot of nice things all together with this technique.